Welcome everybody. Today let us see the numerical example for simple linear regression. Let's see the example of bank loan sanctioning. Let us assume a bank manager wants to know how much loan he can sanction the loan recipient depending on the loan seeker's salary. Borrower's income and loan amount pending are given as input to the linear regression model. His loan sanction data is taken as input. The borrower's income in lakhs of rupees is shown in the second column. Third column shows the loan amount sanctioned in lakhs of rupees. As linear regression is all about determining the slope and intercept of a line equation, let us start with the initial slope and intercept value as 0. Let us assume the learning rate A as 0.001. Number of data n is 5. For all values of annual incomes, we calculate the predicted loan amount OEP as mx plus c. The predicted loan amount is shown in column 4. The difference between predicted value and the actual value of Y is shown in column 5. The product of these differences with x values are shown in column 6. Sum of the differences of predicted and actual Y values is shown in the last row of column 5. Sum of product of the differences and x values is shown in the last row of column 6. Let us recall, by gradient descent algorithm, change in intercept is 2a by n times sum of the differences of predicted and actual values of y. As a is 0.01 and n is 5, 2a by n is 0.004. Del C is the product of 0.004 and minus 87, which is minus 0.348. The new intercept value is the old value minus the change in value, that is 0 minus 0.348, that is 0.348. Again, by gradient descent algorithm, change in slope is 2a by n times the sum of product of the differences and x values. As 2a by n is 0.004, del m is the product of 0.004 and minus 463.5, which is minus 1.854. The new slope value is the old value minus the change in value, that is 0 minus 1.854, that is 1.854. For the next iteration, slope becomes 1.854 and intercept becomes 0.348. The predicted y value is calculated with this new m and c values and shown in column 4. In the same way, the differences between predicted y values and actual y values are calculated and shown in column 5. Column 6 shows the product of x values and the differences. Their sum are shown in last row. As we have done earlier, change in slope and intercept are calculated. From that, new slope and new intercept values are calculated as 2.77 and 0.522. With these new values, next m and c are calculated. This process is repeated until convergence or till the maximum number of iterations is reached. In the same fashion, slope and intercept are calculated for each iteration. The table shows the slope and intercept values at the iteration mentioned, that is at 1, 10, 100, 500 and 1000. Figure shows the regression line formed at the end of first iteration. As it is seen, it is very much away from the actual values. At iteration 10, it moves nearer to the actual y values. On further iteration, there is slight change in the intercept value. It is seen at iterations 100 and 500. Maximum number of iteration is chosen as 1000. The final regression line at the 1000th iteration is shown in yellow color. Once the maximum number of iteration is reached, we get the trained simple linear regression model. Let's predict the loan amount to be sanctioned for 3 different loan seekers' data. One with low income, one with medium income, and the third one with high income. For the trained regression model, the final slope value at the 1000th iteration is 3.437 and the final intercept is 1.925. The loan amount to be sanctioned is predicted with this M and C values and shown in the table. For an annual income of 3.5 lakhs, the loan amount to be sanctioned is predicted as 13.95 lakhs, and for 7 lakhs it is 25.98 lakhs. For the annual income of 9 lakhs, it is 32.86 lakhs. In this example, we have seen how simple linear regression model is created for previous loan sanction data and how it could be used for predicting the future loan amount to be sanctioned. Thank you.